give a couple more minutes for people who are trickling in.
You can't just say, like, well, yeah, you could qualify it.
This check speaking or okay. Oh, I had to share did I share my screen? No, right? Oops, sorry. Okay, looks like we have a quorum, enough people online and people here in person. Welcome. If you're joining us for the first time, this is University of Arizona Data Lab. We are part of a data science institute and we are conducting a workshop series known as Introduction to Deep Learning. And the core idea of this was to introduce deep learning in a hands-on way to people who are not from a computer science background, so that you can take this to your lab and try to use deep learning in whatever you are doing with a quick turnaround. So we usually meet every Thursday at 1 p.m. In the same place in person, which is room 212 in Weaver and Science Engineering Library. We'll keep going until end of November, except Thanksgiving Day. So today we are going to look at some of the architectures of transformers. And in fact, towards the end of it, we will actually look into GPT, or the most well-known transformer architecture known as GPT. And the goal today is to try to understand these architectures and like how they came around, so that when you start on with GPT, you at least have a better understanding what you're doing. And the way I have envisioned the course from now on is, today we will get introduced to GPT, not chat GPT, but GPT as a neural network or as a transformer model. We will first understand how the architectures work. So let's see, I'm gonna try this. Okay, so we'll probably look at some of these standard architectures known as encoder, decoder, sequence to sequence, or combination of encoder and decoder. Then we will look at what does GPT do specifically, which is different than all the models that came before it, or in short, what is making GPT so powerful. We will look at the type of encoding known as byte pair encoding, which is also one of the things that GPT introduced. And then we will have a hands-on where we will try to access the OpenAI API, which is OpenAI is, of course, the company which created GPT. And we will try to access it from a API or an interface from a Python code, so that you don't have to always go to chat GPT, but you can use it in your data sets. So let's look at what we saw last time. So transformers, we saw there's a bunch of things we can do with transformers, like pre-training. So At this point, you'll probably realize most of these kind of means the same thing, because pre-training is what we will take a large transformer model and train it on something big and huge. So before GPT, the big and huge was, a data set of sentences which has 100,000 data points or 100,000 sentences. After GPT, pre-training kind of means training it on everything under the sun, or assuming internet is under the sun, everything on the internet. And the second step, what we do is what we known as transfer learning, or even these days, people use it interchangeably for fine tuning. So essentially, if you are just taking the pre-trained transformer model and using it for a small task of yours, a very subset task. Say the typical example I gave last time was we have GPT, which is trained on everything under the internet. But now, if you ask it about very rare diseases, it probably doesn't have so much knowledge because rare diseases are rare. But let's say you have a data set of rare diseases, or let's say symptoms of the rare diseases. And what you do now is you fine tune this model, the transformer model, so that you can transfer the learning. So it's a combination of transfer learning and fine tuning. Essentially, you're taking all the big knowledge that transformer learned or GPT learned from the internet, and you're telling it, let's fine tune you and make you very precise on this small data set known as rare diseases data sets. So this is what we saw earlier. For example, this is one of the earliest examples of transfer learning, there was a model known as convolutional neural network, or CNN, which was trained originally on identifying cats and dogs, but then we fine-tuned those weights and made it identify things it has not seen before, like a car or truck. And you saw this earlier, that a very eagle-eye view of how transformers work is we take the input, which is usually raw text, tokenize it into these independent tokens or words. We throw it into a black box known as model, and then we do a bunch of post-processing so that it can predict, one, for example, like, is the review positive or negative? And we already went through a little bit slightly more fine-grained look into transformer. We saw that we take the model, we have things known as embeddings and layers, and there are a bunch of these hidden states, and this couple of terms you just have to be aware of. Today, like I said, we'll go a little bit more deeper into how do these things really work. So this is how the history of transformers since the first time transformer came out in 2017 from Google. There are three major classes of models which has come out. First one is known as encoder only, which is, you probably encountered this, not probably, we encountered most of this earlier in the last few lectures, which is BERT, Robert Distelbert. If you have been playing around with Hugging Face models, you would have encountered these tasks. Then there is a model known as encoder-decoder, which has things like BART and T5, which was one of the original large language models. And then there's only a decoder-only model, which was one of the innovations of GPT. And we will get into details of each of these. But I just wanted you guys to understand this basic eagle-eye view of the definition or distinction between all these three major classes of transformers. Now, what are encoder-only models? So encoder-only models, for example, are useful for tasks like sentence classification. We saw that earlier. And something known as named entity recognition is a very common task in natural language processing. So for example, the task is, if you are given the word Washington, are we talking about George Washington, or are we talking about the Washington, DC, or the state Washington? So this was a task typical in natural language processing we use neural networks for. Decoder-only models, sure, they are known as generative tasks, like GPT stands for generative pre-trained transformers. And that's what they are really good at. For example, you're familiar with ChatGPT, which is really good at generating the text. making it classify sentence is difficult, not impossible. We, as you're familiar, you can probably give it to as a prompt and ask it to classify if this reviewer positive or negative. But then it gets trickier when you have a huge data set yourselves and have to train it for sentence classification, etc. We will look into that also soon. And encoder decoder is what we know as sequence to sequence. And one of the major use of that is translations. I just wanted to introduce these few terms or usages before we get into the details. So what is encoding? What do we mean by encoding? So since we have a lot of participants from non-computer science background, encoding is a very simple thing. For example, when we talk to somebody over the phone, right, we are actually taking the ideas in our head, speaking it out into words, and the word is getting encoded into the communication media, which could be phone, texting, whatever. So that, and the person on the other end is decoding it. For example, when we are actually sending a text message, one line, which says, I will meet you at the bank, we are kind of encoding a meaning that, hey, hopefully the person on the other end understands I'm talking about the financial institution bank and not the river bank, for example. And the person on the other end is decoding it in a way with your human brain, and like the person knows you and the context you are usually talk to the person about, and says, oh, he's most likely talking about going to the bank. So that is your typical encoding. Like anything you use on a daily basis is encoding. In fact, words are also encodings of this abstract concept of meaning in your head, right? So typically, in computer science, the word encoding is used for converting text into bits or bytes. So as you know, computers work on zeros and ones. So every word you type is actually converted to a 0 or 1. So this is typically what we use the word encoding for in the computer science world. Now we saw this kind of example earlier. This is what we call one-hot encoding, which simply is, let's say, we have a sentence which, has a lot of these colors in it. The sky is red and rivers are blue, whatever. And one-hot encoding simply says how many times does the word red occur in the first sentence and how many times does green occur in the second sentence, etc. So this is a very basic definition of encoding. However, when it comes to transformers, it gets kind of slightly complicated. We call it word embeddings. And simply put, word embeddings are just a vector or an array of numbers or floating point values to represent every single word. So right now, as you can see, man has an encoding of this vector. The size of the vector is very dependent on the architecture you're using. But the idea is that very similar to the idea of man in your head being encoded into the word man, this is exactly what we are trying to tell the machine. The word man actually has this spread multi-dimensional representation in terms of vectors. And that is what we usually feed into the machine. In this case, I'm calling machine as a transformer. So the basic idea remains the same. Like earlier in computers, we wanted to tell it, let's encode it in terms of byte. But simply now for neural networks, we are encoding it in terms of these word vectors, also known as word embeddings. Now, there is another encoding that is very quintessential to transformer architecture, and this is known as attention. And the idea of attention is very simple. Let's say we have a sentence. He later went to report Malaysia for 1 year. So you can see on the row and the column, or x-axis and y-axis, it's exactly the same sentence. He later went to report Malaysia for 1 year. Attention is simply comparing one word against the other and asking the question, which word is the most important given that word? So let's say we take he. So clearly, he in the other sentence is most important. But if we look at later, if you think about it, later really doesn't have too much connection to he, right? Let's say, for example, report and Malaysia. So report and report clearly has, so this is what we call a heat map. If you're colorblind, doesn't matter. It simply means the stronger the color, the higher the attention is. So this is the basic idea, like self-attention, which is the same word to same word, is always the highest, which is why the diagonal is almost always the strongest color. But there is this whole idea that, sure, report to report is highest, but what do you mean by report? What is the attention between report and Malaysia, right? So that is slightly report and Malaysia, right? Okay, so here is a little, the color is not so strong, but as it goes down here, this is a relative grading. So within this sentence, if I ask you which is the most important part of this sentence, it really is report and Malaysia, right? If the guy went somewhere, but why did he go there? So he went there to report on Malaysia. That's exactly what attention in transformers does, is basically trying to teach the machine, here's a matrix, find which word is important given all the other words. It gets more interesting when, so this is boring, right? Because it's the same sentence. We expect the heat map to have all the diagonal center, the center diagonals to be the highest color. But it gets more interesting when we go into more complicated problems like translation. So on the x-axis, I want to call it, the sentence is the agreement on the European Economic Area was signed in August 1992. And there is a token known as end, which is a typical, how do we, tell the machine that the sentence has ended? Remember, we could probably tell it to look for periods or as the ending of sentence, but that's not always true, right? Some sentences might have 3.5, and then the machine is going to get confused. So people have started using an explicit end token at the end. But look at the heat map, right? So here it gets more interesting when the machine has to correctly classify which word corresponds to which other word, or which word in French, y-axis is French, l'accord sur la zone, I'm going to kill this in a bad way, la zone économique européenne a été signed, whatever, right? I don't want to even try. So this gets very interesting problem. Like when we start this matrix, when we start the training, this matrix is same color, like completely black. But slowly the machine starts learning, oh, this word is corresponding, signe is corresponding to signe, maybe, signed, right? So this is the final matrix representation. In fact, if you just look at this example, you can actually see that, the more interesting thing comes into picture when we have sentences which are not the same as the other sentence, right? Should a robot obey orders from humans? A robot must obey the orders given it to by humans. And we can actually trace, this is what we call the attention mapping between each of these words. Like given the word obey, right? Which word is correct corresponding to the word obey in the other sentence? Yeah, so more interestingly, think about it in a meaning perspective. Like the sentence on the left is asking a question, should a robot obey orders? And on the right, it actually says a robot must. So if you actually trace this, we can actually see that the most likely the word should will be given highest importance when compared to must. So you're asking a question and the machine automatically learns the answer is must. So this is then actually, in fact, if you will probably, this is also uploaded into our UA-DataLab. There is this amazing visualization. All right, never mind. Yeah. So this is known as Bert Wiss. You can actually give it any sentence you want: cat sat on the mat, cat lay on the rug, etc. And you can, this will take it through all the sentences in all the layers in Bert. And you can actually point, right? See, okay, so this is complicated because this is a sad truth of transformers. It gave a lot of attention to the separation words, but you can actually visualize this and play around with this, and you can see how the attention changes between all these words. Anyway, just wanted to give you an example of what attention means in terms of transformers. Now, great. So transformers did something known as attention in 2017. What was the big thing that completely took GPT and it just ran with it? Like, as you know, like in the last 1 year, the kind of advances GPT has done is, you cannot even explain to anybody like from 5 years ago. Imagine somebody telling you, right? You'll have a chat interface publicly available for people, which can answer almost anything. Like you would say, isn't that what Google does? But as you know, if you have played with ChatGPT, it's not that simple. It can do way much more tasks than Google, right? So what did ChatGPT do? So what it did was it took the encoder-decoder model. So remember I said, when we looked at the examples of what task is good for what, we had said, okay, encoder-decoder is the architecture which we use for sentence classification, encoder-only models. So that was the original paper. So when they created transformer, they said, okay, let's take these big embeddings, let's run it through a bunch of neural networks, and the output of the neural networks, what we call code here, it's like an intermediate representation. It's an abstract representation in terms of meaning, that you can think of it that the machine has compressed the meanings of the words into something very small and like an intermediate language. And the original paper discovered that that's enough to do tasks like sentence classification. But then people started reversing it, kind of like, let's create a mirror image of the same architecture after this, and let's call it decoder, right? And that people found out that was very useful for translation tasks from one language to another. So then from 2017 to 2023, in the last 6 years, people started playing with this architecture. Basically, what is the best combination of neural networks as an encoder? Does it have to be exactly a mirror image? Can we have different architectures? So people started playing around with it. And then they realized, so this was the typical encoder-decoder, architecture from transformers. Recently, in the last 1 or 2 years, people at OpenAI realized that to have a best performance, we really need only decoder, right? So that gets a little intuitively complicated. Like, how can you have only decoder when there is nothing which is encoding the meaning into a very compressed form? So I think this slide is coming later. This is, I was saying, like the typical encoder-decoder for translation. But the more interesting part is, let's look at what did GPT do, or how did it do just by using a decoder model. So remember, we are here on the right side, which is decoder-only models, and how this decoder-only model just took off in the last 1 or 2 years. If you can see, like it started only in 2019, 2020, and from there it was amazing, just took off, right? Completely a decoder-only model. So they use this whole idea called auto-regression. So what is auto-regression? If you remember this example from a couple of days ago, couple of classes ago, like a couple of weeks ago, the whole idea was, first we give one word to the model and say, my, right? And we ask the model, what do you think is the next word? And the model says, my book. And then we tell it, oh no, we want you to say name. All right, so then we do the back propagation, and the model learns, okay, if I have I should say name. Now we give it my name as input and ask the model, what is the next word? It says, my name could be, right? And we say, oh no, we want it to remember is. So we keep playing this game of auto-regression. This is exactly auto-regression, like back and forth. But instead of one sentence, we now give it everything on the internet. And now it's slowly learning this whole idea of the word name almost always occurs with is next to it, and my follows, my precedes name, etc., etc., and very things like that, what we call context. So surprise, surprise, when we ask, after all this training, we ask GPT, recite the first law. And if you don't know what this is, these are the 3 laws created by Isaac Asimov almost a century ago, maybe in this, I'm going to say century, no, half a century ago. And Isaac Asimov came out with this whole idea that, if we have machines which become intelligent, or he called it robot, which comes from a Czech word created by this author known as Karl Capek, but that's a different discussion. But his idea was, if a machine becomes intelligent, what are the three major laws we want it to follow, like the golden rules? And the first law was a robot or may not harm human. So if you have watched all these AI movies like iRobot and things like that, these robots get so smart enough that they kind of find nuances of, get away with that rule and how they start harming humans. Tangent. But my point here is, right now, after all this training in autoregression, if I ask the machine to recite the first law, it will just start saying a robot may not and keep filling it up, right? So this is exactly autoregression, because it was trained on a book by Isaac Asimov, word by word, and which was exactly, this is what the sentence was: recite the first law, and the next sentence was the robot replying, a robot. So you gave one at a time. Yeah, same things, kind of putting it all together. We just give just this sentence, no encoding anymore, just this sentence, give it to the decoder. And this is what we saw earlier, the self-attention idea, that given this sentence, given this particular word in the sentence, which one is the best word to give maximum attention to. So there's another invention that OpenAI did not come up with this invention known as byte pair encoding. It was already there since 1957. In fact, neural network itself was invented in 1961. So none of this is new, but it's just old wine, new bottle, happened to be at the right time when we have so much power in terms of GPUs and compute power. So this was this whole idea known as encoding, like a subword encoding, right? If you remember, we saw this already, which is old occurs 7 times, older occurs 3 times. And this is like a typical one hot, vector. We are trying to identify how many times does a given word occur in a sentence. But the subword encoding takes it to a different level. First thing it does is adds an ending token to say this is the end of the word. And the next thing it does is it splits the whole word into individual characters, right? O-L-D-E-R. It basically finds all the unique characters in all these couple of words we saw earlier and starts counting the words. And /W is 23, which simply meant in this case, the number of words, not unique, number of words was in that given sentence was 23, but it all happens to be captured by these. It was either old, older, finest, just an example, right? Now, what they started doing was, let's look at combinations of things which occur a lot, like ES. So if you go back and look at the word, oh yeah, that's true. Finest has ES, lowest has ES. So that seems to be a good sub-word to start. They are just doing a kind of encoding, a compression. As you can see, like they start with ES and then they realize, oh, EST occurs so many times. So let's look at EST then, right? So they keep finding these patterns, like EST with the ending token occurs more than if you take any of these individual characters alone. So they are basically trying to find these patterns, so on and so forth. And they, within this given sentence, they just call this, different kind of encoding. Now, if you ask me, why did they come up with this encoding? My answer is, this is pure trial and error. I can promise you there was no linguist sitting there and looking at it and saying, oh, this is the best way to do it. They just tried doing it, happened to work and give perfect accuracy or the highest performance. But more interestingly, these models really, really work simply because of the size of the models or neural networks, or specifically what they call parameters. Parameters is, if you remember from our original class, it's simply the weights between one neuron to another neuron. How much weight do I want to assign? So kind of parameters translates to the total number of neurons. So I think GPT-4 is hitting trillion at this point, but it started with 117 million with GPT-1 all the way to 175 billion parameters. And all these are trying to learn these kind of patterns within a word and within a sentence. So within a sentence is all the context. So, put all these together, throw it a huge amount of resources in terms of compute power, and you get GPT, right? So this is, okay, some other terms. Now, these days, this all is like mixed up together. This all had separate meaning in the pre-GPT era. Essentially, if you hear zero-shot transfer, meta-learning in context, etc., it all essentially now boils down to this one word known as prompting, which you're probably familiar with your interactions with GPT. Your prompting is basically saying this thing that you give GPT, which is pretend you are Siri, an extremely foolish AI made up of a number of if-else paraphrases or phrases. When I say, hey, Siri, you answer. So it has all come down to this one single idea called prompting, where we are trying to tell the machine that, hey, we are going to compress and give you a bunch of context for this given question I'm going to ask. And you have to collapse all your big learning and transfer it to this one single prompting and give me an answer, right? We are literally like jump starting that particular entire huge learning of GPT and asking it, here's the context. Give me, what do you mean? What do I want essentially in life, right? So next week, we will get into details of it, because now there are entire companies and people making their living purely from what we know as prompt engineering and prompt tuning. And a lot of these things that we can use for making answers from GPT more simply better, right? Now, then there is this big question, right? If we can do everything with prompting, why do we even learn fine-tuning and the whole ideas? Point is, there's same example like the rare diseases, right? So there is only so much you can do with prompting. If you have a data set of rare disease symptoms, how do you, if you have like 10,000 symptoms, right? Do you actually paste it into a prompt and then tells, hey, GPT, can you answer this question, right? So which is where the whole fine tuning is going to come into. So this is what we will try to get to next week, how to do prompt engineering, prompt tuning, and even fine tuning. And my goal is to, by the end of the course, you should be able to create a chat bot, which is purely fine tuned on your own data, a chat bot which internally calls GPT. We'll see how we get there. But to get there, we start with how to get an API access for OpenAI. So let's go to this guy, GitHub. Okay, let's go to GitHub, UA-DataLab, repositories, TL workshops, deep learning workshops, Lecture4, intro to GPT. All right, and if you can open this guy. Now, couple of things, if you are not familiar with OpenAI already, I'll just say it anyway, right? So OpenAI is a completely closed model. Okay, sorry, let's go to openai.com. If you guys don't have an account, create an account. Oh, okay, clearly it's not letting me. Okay, never mind. But more importantly, you should really have something known as a login. So give me a second. Let me see if I can log in again, or an API key. I'm going to get to the API key in a second. Yeah. All right. Just create an account on OpenAI if you haven't yet. Let me try doing my login meanwhile. Why is this? Okay, give me a second. Stop sharing and see if I can log in. This one off. Oh, I know. I was playing around with this before I left. Okay. All right, go ahead. Let me share my screen back again. Ta-da, ta-da, ta-da. Nothing wakes up. Okay, perfect. So the reason So let me start with this. Okay, if you already have an account, right, you can even, I think, you log in with Google. The first thing you need to go look at it is your API keys. If you don't have anything here, create a new secret key and you can call it test, right? So create secret key, it will create your test, another secret key, right? You copy this but this is important. This is the very first thing you need to do if you want to access these APIs from command line, or sorry, in this case, Python. The second thing is, if you're not familiar with this, please go to Playground OpenAI. And by the way, the moment you log in, you should probably have some amount of basic usage, or let's call it billing, right? So you should have some credit, like I clearly used up all of it. So I'm assuming you have some basic credits because I think you get like $1, very helpful. So this is, like I said, if you remember, I was trying to log in and it didn't let me log in. Wait, which share screen am I sharing? Am I sharing this screen, right? In the Zoom call?
Yeah.
Okay, cool. Same screen, right? Okay. So this is the sad truth of these days, like you cannot really use it without paying for it. But Playground, you should still be able to like use all these models. You know, you can use it to chat, you can use it to complete, and all these. This is literally a playground. Like if you don't want to really start working on ChatGPT itself, let's get back to what we were doing, right? So
does the OpenAI account require a phone number?
correct. It requires a phone number, which is exactly why it was not letting me sign in, because the phone number is, the question was, does the OpenAI require a phone number? Yes, and it's trying to uniquely identify you with the phone number. When I ran out of my usage or the amount I had, I said, okay, let me be smart. Let me try giving it a VoIP number, like Google Voice number. And it said, nope, you really need to have a good phone number. So sad truth, sad but true. But let's see what we can do without it, right? So the first thing you need to do is open this in Colab if you have not yet done. Couple of these things, like first, of course, OpenAI is the pip install. Tick token is just essentially, if you heard about, remember we were talking about byte pair encoding. This is just exactly that, like pip install tick token. And they'll tell you like this tick token is a fast byte pair encoding tokenizer used for OpenAI models. So these are the two things you need to install before we get into this get into using OpenAI Access. Now, key, right? So we went to that page where we were trying to get the OpenAI key. Let's see. Okay, I lost the page again. OpenAI.com. Don't ask me to sign in again. I just did. Oh, never mind. Let me see if I can find the page. I opened. There you go. Perfect. Good. So go to your API keys, right? Copy this key if you can find it. I don't know why it doesn't show me. Anyway, what I did was I copied the key here, right? I put my key here. And remember, one thing is you should almost never share your key in public. So this is clearly not my key. But the idea is the moment you put this key up there in GitHub, somebody's going to copy it and use it for themselves, especially if you're in a paid version. So you should always try to read it from your from a file which you have on your local machine. And but let's move on. So what we're going to do here is we are just going to import a basic few things. Arg parts, if you're not familiar with this, just you can pass an argument to your from the command line to your Python program. Import OpenAI, you can ignore logging, you don't care. And these are all like external, like if this is very typical good Python coding, which is like, let's always use logging, let's always use argument from the command line so that we are not hard coding anything. Path is again simply saying, I don't want to type my path as a text variable. I want to add it as a PATH class, which Python provides. But here, what I do next is I create some variables, like basically saying, hey, I want to use this model, DaVinci. In this case, I don't think that exists. It's not open anymore. Let's see if OpenAI models are OpenAI models. Right. So I think they yeah. So so it used to be DaVinci, Ada, and all those things, and it all went under deprecated, I think so. Yeah, it's all DaVinci. So that kind of like, tightening the noose and pushing us into pay for these models. Otherwise, you're not going to be able to use it. Read arguments, you can just essentially, this is boilerplate code. I'm reading the argument from the command line. Again, like I said, it's a good habit to always read it from a file, your OpenAI key. But let's get into more interesting things, right? So import tick token. And so if you can see, let's start from the main, right? If you're familiar with main, I cannot run the arguments from command line here. So I'm just commenting it out. You should be passing it to this command, this function here, make GPT 3.5 recommendation. And if you look at this function, all I'm doing here is first step, let's encode it, encoding for the model, right? Use tick token. And here you saw that like I created a prompt, which is, let's say, return the answer in one word. I was asking it, does the passage authorities say 7 Folsom State Prison inmates are hospitalized, blah, blah, blah. Does it entail, contradict, or is neutral? Like I created a task on myself to people gather, right? It's just, I'm asking it, you can ask any prompt you want as you're familiar with ChatGPT. So if you want to see like, well, how did the encoding look like? You can actually pass it a text, right? And okay, so this is a good thing to keep max OpenAI input tokens, because you need to have control on your own tokens. Otherwise, it's gonna come and complain that, oh, you just used up all of $1, or if you're of course paying more for it, right? So once you have that, all you have to do is this one single sentence. So essentially, you are trying to give it this and saying that, hey, here is my sentence. I'm pretty sure I'm not even passing it the text anymore because I was playing around with this, but you get the idea, right? So here is the text, is you are giving the text, and the idea is, this is just to standard boilerplate stuff. You just tell it, hey, content, and this is very nice. Like they have this hard coded, which is like, let's give, let's put some good happiness into the machine, and we are saying, hey, let's start with your helpful assistant. It's almost like if you take over the world, you should remember we were the ones who said thank you and happy to you. And all you do is I pass the text, which is my prompt here, right? My prompt was passed as a text. And you can do all these things. Max tokens is, I think when you pay for it, there's only so many number of tokens. It'll tell you like, there's only so many tokens you can use. And I think there's a bunch of things, yeah, and things like that, right? The number of tokens per minute and all those things, you can play around with this, but you must be on a paid plan. And that's it. So it replies, that's it. So all you're doing is this, and it says, let's respond with it, right? So let's respond, and that's all you need. And now, clearly, it's going to tell me my OpenAI key is wrong. So let me see if I pass for the smart way I hid my key was to change the last G to F. Trust me, you won't have there's no point copying this key. I'm broke. But the one thing I wanted to show you was, okay, what was it? All stupid things. Where is it? No, because we did not define it. We did not initialize it. Let's run this guy again. Nope, not helpful. OpenAI underscore key. Nope. All right, this is where I got stopped, which is like, hey, I don't have money. So if you had money, this is how we would want you to, we will reply to you. But if you, so maybe by next time, I'll see if I can get the department to pay for it. But more interestingly, one thing you can do is just go to this here, right? Where was it? Tutorials, maybe? Yeah, so here they will kind of tell you like, this is a good page for that. You can just look at this and say, hey, how do I pass all these things? If you're familiar, if you just have a Linux machine or an OS X, you just need a curl command. You can just copy paste that. So most of the things I went through today is just boilerplate from here. How do I make requests? So making requests is just this, right? So, hey, you are a role. This is a boilerplate again. I'm a user, and this is your content. That's it. And Okay, temperature. Temperature is a very interesting concept. It's a very deeper idea from the architecture world. Temperature is simply saying how much, let's see the official definition of temperature and OpenAI, right? So again, I mean, you can just do 0.1 or 0.7, but the whole idea is it's like a tuning mechanism, right? It's kind of controls the randomness of the output, because if you remember, so the higher values are more random, lower values are more deterministic. And the reason is, if you go to ChatGPT and let's say phishing detection, right? So I asked some question like, rephrase this. Many researchers have proposed this, and it rephrased something. But if you click on regenerate, right? So this is it's not gonna give the exact answer, right? It's gonna give a different answer this time, second time. So that is the non-determinism of GPT. Sad truth, this is what happens if you learn only from context. But if you want it to give the same answer again and again, you probably just need a temperature of 0, right? So that's a temperature value here. Yeah, okay, that's all. Yeah, so the same stuff, like this is all, you can just copy paste this stuff. And you know, at this point, if you want to try out new things, there is speech to text, transcription, and things like that. But I just wanted to introduce OpenAI GPT from an API access. You need your OpenAI bearer key. And once you have all that, everything else is copy paste. Next time, we will slowly get into the whole world of fine tuning, which is the more interesting thing, because everything I showed you just now can be done by ChatGPT itself, right? You're just sending the same prompt from a command line. So next time we'll start looking at how do we load the data set, how do we fine tune it and use GPT behind it. Because if you remember, we went through Hugging Face, and the reason I went through that is this already has GPT-2 for free, right? So we don't need to really like use all these. So there's tons of these GPT models we can use for free. Or even better, like, you know, if you're familiar with Llama is open source, so we can, you know, so that is why I taught you Hugging Face first. Now you're not stuck with GPT or any of the paid ones. You can use Llama or any of the other open source large language models. So we will look at it next week. So we are almost out of time. At this point, let me open the floor up for questions. Is there a question? Okay, let me ask first in the class. Is there a class in person? Is there a question you guys have? No? Okay. Let's look at chat. Anything? No questions? Okay, it's all check-in kind of questions. All right, if anybody has questions online, please unmute yourself and ask a question, please. Hopefully I am loud. Okay, I'm gonna say that's a no. So we are at 50 minutes, almost 2 minutes from there. I will call it a day, or just bring this to an end at this point. So yeah, drop me an email if you guys really want. There's some topic which you really want to be seen in these lectures, right? Let me see if I can pull up. Don't know how to bring my screen back up. All right, there you go. This is my email. If you want, there's like, or even feedback, like positive, negative, constructive criticism, non-constructive criticism. You hate me, you won't buy me a beer. Thank you. It doesn't matter. But if there's something you would really want me to cover, like my goal, like if you remember, I had shown you this. This is a plan for the whole class. Let's see. Yeah, so I think we are at this point, like we started learning transformers. We've learned how to train and fine tune a model. I was thinking of training a model from scratch, but then I realized GPT at this point is probably better because it's already well tuned. You're probably better off with fine tuning GPT. And I'm gonna get into all these tools. Like once you know how to do this from code, we'll introduce you to all the whole AWS or a Cyverse. Oh, that reminds me. Please go to Cyverse and create an account, cyverse.com, and also AWS account. We might need it next time. Oh, Jesus, Cyverse.org. All right, cool. Cyverse.org. Okay, so these are all tools which will let you do things with a click, right? Basically, everything you did from command line, you can load all these models straight on. You can get AWS will get you upload a data set and things like that. I think I moved this up there, which is how GPT works. So next week we will look at fine-tuning GPT. Let me change that now itself. So we moved this there, how GPT and large language models work. So now, and next week we'll do a fine-tuning of GPT or any of the open large language models, right? So this goes there. So that was one of my thingies is like, I'll introduce all this multimodal thingy towards the end because sure, we are stuck with text, but eventually you want to, of course, play with images. And for images, right? So text, you probably can run it on Colab, Cyverse, good, but sorry, Colab or AWS. Images, Cyverse is very useful, especially for the data size of data. Like AWS is paid and Cyverse is free. So it's exactly like Amazon Web Services or AWS for SageMaker, right? So you can just make. I think if you log into AWS, you will get create an AWS account. So the whole idea of I was asking you to create AWS so that we can go to SageMaker, and SageMaker is simply let's see if I can log in and show you some stuff. Ta-da, 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 ta-da. I'm still sharing the screen, right? Okay, yeah. So let's see. SageMaker is like a very nice interface where you can take things from a drop-down list, but there's only so much you can do for free. But Cyverse is free, so which was created in University of Arizona. Now it's being used by a lot of these, lot of people in the US and outside the US. And more interestingly, it'll give you access to big machines like GPUs and CPUs. Jetstream is, this is an initiative from NSF where it will tell you, like, you just write one piece of paper, say you're a student, one page of paper, say I want a 100 GPUs, and next thing you know, you can connect it here and start working on it. So we are trying to get to a place where we are not dependent on closed architectures like GPT, but still can run things open source, even do a full-fledged training from scratch. So yeah, for next time, if you can get like accounts in Cyverse and AWS, please. Question?
Cyverse is free for UA students. You have to use your Arizona.
Okay, the comment is, if you are using Arizona.edu, Cyverse is free. I don't think we have anybody from outside Arizona in these workshops. So yeah, a couple of beasts I wanted to introduce. Like I thought, okay, let's start with this, hands-on stuff where if this way you will learn how to really train a model and call it. But once you're done with that, we can start, sending it directly onto Cyverse, start running everything on Cyverse or whatever you want to decide to use. Okay, any other questions, anything? Yeah, I'm just showing you, like, you can use this. Llama is straight on there. This is open source, and you can use this on AWS. I think sooner or later, they'll ask you to pay. Yeah, you can, this is all available on AWS at this point. Hugging Face is more extremely open source, doesn't make any money out of this. And Cyverse is too. Amazon slowly starts making money out of this. So yeah. Okay, that's all I have for today. If you guys have any more questions. Okay, Meg says, please check in for today's workshop. For people on campus, there is a QR code which you can scan. Sorry, did I say on campus, in person? That's all I have for today. Thank you, guys.
Yes,